This is Dr. K. Rajendra Prasad. I am working as professor and head for the Department of Cyber Security. Today my topic is regular expression. So you have to see that the regular expression is very important because of we have to recognize the tokens of the particular language. The tokens are token patterns that can be recognized by some simple kind of expressions which are called as regular expression. So there is some interaction between the language and automata, that is language and finite automata, and one more interrelation is between the finite automata and regular expression also. So means there is some interrelationships between the language, finite automata, and also regular expression. So first we have to see, so what is the basic idea of regular expression? Regular expression that can be defined as a language means language strings. Language nothing but it can be formulated with the help of the respective valid strings only. Means any string is valid nothing but may not be valid. So we have to go for the language definition is as a set of valid strings. This about language. So we have to express all valid strings of the particular language by some simple expression that is called as regular expression. And we have to defining it is also called as string. So language or string, the meaning is language nothing but a set of strings, set of value strings which are already recognized by finite automata. The meaning is which are accepted by the finite automata. Those kind of valid strings that can be defined by some simple expression, that expression is called as a regular expression. A regular expression can be defined as a language, a string, accepted by a finite automata. And we know more about the idea about the regular expression with the help of the one particular symbol of finite automata syntax. So we have to visualize the finite automata definition is with the 5 tuples. So what are the 5 tuples? Nothing but set of states, Q, an input of a bit, and transition function delta, and Q naught is the initial state, and we have to ending with the accepted strings. Those are called as set of final states. And here, among these, here come to regular expression point of view. You take the second tuple of the finite automata. The second tuple of the finite automata is sigma. It may also call as input alphabet. It is called as input alphabet. The input alphabet and generation of the strings, generation of the language value strings by the input alphabet, those are recognized by finite automata, and these recognized tokens or patterns or common patterns of the particular language or common patterns. We have to say that the valid strings of a particular language that can be expressed by one expression that is called as a regular expression. So we have to given the idea is regular expression is a string. The string is generated from sigma star, sigma or sigma star. That is only for whatever symbols are defined in the sigma. With the help of those symbols, we have to generating some kind of strings. But which are accepted, you can find out those strings that comes valid strings only. Not all strings are the valid strings. So generation of the strings from the alphabet sigma, only from that case, only for few of the strings are accepted by the finite automata. Those strings are called as valid strings. So those valid strings that can be expressed by some common expression, that common expression is called as regular expression. So that's why regular expression denotes the pattern of symbols that associated with the language accepted by the finite automata. It is a major idea of regular expression. Means we want to define some kind of expression, some kind of common expression. That common expression that can be described the some valid strings of the particular language as well as regular expression. Come to that what is the interrelationship between the language, finite automata, and also regular expression. L is nothing but language, FA is a finite automata, RE is a regular expression. Means you want to recognize particular tokens or particular patterns of the particular language or value strings of the particular language. How can you say that which those things which are accepted by the finite automata? So means here you are taking the language nothing but some set of strings, a set of valid strings. So what do you mean of valid string is that valid string that may be accepted by the ideal machine's finite automata. So when the string is accepted by finite automata, then it is called as valid string. Set of such as valid strings is called as defined as a language pattern. Means that the language rules and grammatical things, syntax of the languages based upon that you are trying to generating the valid strings only. Those valid strings that can be accepted by the finite automata. And you want to take one common expression only. Means in the language we have so many number of valid strings, string 1, string 2, and so on, nth string. But we cannot take the n number of different expressions. For representing the all valid strings of a particular language, we use only for single common expression that is called as regular expression. Means I want to go for generating the patterns are like this. The meaning is every time I think maybe for the number of occurrences of the years are increased. So for representing all these strings, we use only for single common expression that is called as A star. It's called as A star. So A star is some kind of regular expression. This regular expression that can be used for describing the some number of occurrences of the A. It may be for single A, two A's, three A's, and so on. N number of A's. Means here what is nothing but language, and those are means A's are accepted by the some finite automata. Number of occurrences accepted by the finite automata, and from that you can derive the corresponding expression is called as regular expression. So finally, the meaning is regular expression nothing but is some single common expression. This single common expression that can be defined for the purpose of representing the all valid strings of a particular language. So those strings or that particular language accepted by the finite automata. So now we have to know that the some information, interrelated information for different topics are language, what the language, how the language is, you can say that accepted. Suppose after accepting the strings of the particular language, you are reaching to the final state, then the language is accepted. Otherwise, the language is not accepted. So for accepted strings of the language that can be expressed by one simple expression, only for single simple expression that is called as a regular expression. So this is the idea about regular expression. And here I will give what are the detailed information of the regular expression is. So regular expression or the common expression, regular expression or common expressions that describe the or the things nothing but language strings. Language strings. Those language strings definitely that should be accepted by the finite automata. It is the entire idea about the regular expression. Means this definition is telling that what are the interrelationship between the language and the automata. So means you have constructed automata for implementing the lexical analysis of some compiler. Lexical analysis designed for accepting the some tokens or recognizing the tokens for one particular language. Hence, the language tokens are language strings that can be definitely accepted by the finite automata. Such cases, we can use one only for one common expression for representing the given number of strings. Given strings are n number of strings. All these n number of strings that can be defined by one simple expression is called as a regular expression. And Regular expression are used to check and also match the character combinations in the strings. Come to that, what are the basics of regular expression is? Before introducing the basic, first you know that what is the language, what is the regular expression. All it is defined in previous slides. And one more thing is what is the relevance between the regular expression to regular language? What do you mean of regular language? Nothing but some language strings are accepted by accepted by the finite automata that also can be described by some simple expressions called regular expression. And finally, so what expression you have to use from that what strings are generated for the particular language, that language is called as a regular language. Here it may be for regular set. Regular set strings define the language called as a regular language. So we have to see some basics idea of regular expressions. One is called as a pi. Pi is a regular expression. What do you mean of pi is a empty set? Empty set nothing but like this. It's an empty set. So for particular empty set, language is also empty. Language also empty. No symbol. No other symbols, no null symbol also. And that's I think the first basic of regular expression. Second basic is null. Suppose I am taking the symbol, but it is not a alphabet symbol. It is some kind of a null symbol. Because of in the NFI diagram, you make use of some null transitions. For define the null transitions, we can use some kind of null symbol. This is called as a null. Null that can be defined by the some epsilon symbol. Suppose some symbol is there, you are assuming only for single symbol, null symbol is there. What the corresponding set is called as it is not empty set, it is a null symbol set. So there is some lot of difference between this cell and this cell. First is totally for pi, means in the set no element. The second is in the set element is there, but value of the element is null. Value of the element is null. So here number of elements 0, but here number of elements are 1. But what is the value is nothing but null value. Null also consider the sum of the element. Suppose I am taking other than pi and other than null symbol, you take another basic is one single element is there. One single element is there. That single element you have to say that x. That is called as x. So what the corresponding set nothing but the same element x. You have see the differences is the empty set language. This for null regular expression language. This called as a single element language. So what are the L nothing but here you can say that what kind of language is because of the elements of the capital L that can be derived from regular expression. So this L is called as regular language. Why it is called as a regular language is from that regular expression itself only you are trying to generating the elements of the language. So it is called as a regular, L is a regular language. Means here we have to see the conversion is a regular expression. You know the regular expression. From that you have to generate in the language. What kind of language you are generating is a regular language only. The conversion from regular expression to regular language. If you know the expression, if you know the regular expression, from the regular expression you have to guess it what are the elements you are getting. Those elements that can be comprised under the single set. The set is denoted by the language set. So that particular language is called as a regular set. And one more, some of the cases. The previous three cases are totally for the basics of the regular expression. And for after the basics, you want to apply some kind of set operations. You know from the what the basic set operations from the mathematics you know very well about the union and the concatenation. So you what the union concatenation? So that thing is different. Union nothing but from the two different sets you want to match the elements and the element repeated element not there. Suppose elements are repeated, we discuss the particular element is only for one time. That's called as a union. So you come to that this for what the A plus B is. This called as a regular expression. You are assuming or E. This called as a regular expression. So for this regular expression, what is the language? What the language? So from the A, you are generating the language L1. From the B, you are generating the language L2. So A plus B nothing but we have to combining the elements of L1 and L2. So the meaning is, I think, L1 union L2. This understanding of A plus B nothing but A is one regular expression, B is another regular expression. This corresponding set L equal to A, L1 equal to A, and L2 equal to A. The meaning is L1 equal to A and L2 equal to B. And A plus B nothing but plus indicating not for the addition operation, plus indicating you have to merging the elements. You have to merging for first expression and second expression. So first expression element is A, second expression element is B. After merging, you getting means A comma B. That means here you can apply indirectly L1 union L2. So here you should remember whatever the A plus B nothing but which is equal to some you are applying the operation is called as a union operation. The second one is I think concatenation means just you have to go for combine the symbols. Suppose A B you take this regular expression 1, you using this regular expression 2, okay, and these are I think it is in the form of L1 with L2. Sometimes you can make use of dot, sometimes simply can take the L1 L2. Suppose I am taking x equal to AA, y equal to BB. You want to make the concatenation but xy. The result is AA and BB. This is example of concatenation. And one more is the star operation. Star nothing but define the closure. So closure is the basic idea of the closure is it covers null element and number of occurrence of the particular symbol is 1 time. Number of occurrence of the particular symbol is 2 times. So on, number of occurrence of the particular symbol is n number of times. That is the basic idea of a closure. Here I will show that what the closure is. Suppose here I am taking the element is A. Let's call as a regular expression. Element is A, regular expression. So here what the closure is? A star. Nothing but it includes null value, single A, number of occurrence of symbol is 1 time, number of occurrence of the same symbol is 2 times repeated, 3 times repeated, like a number of years. This is called as a closure. Means I want to take x star. First you must include the null value. X is repeated 1 time, x is repeated 2 times, x is repeated 3 times, like this. That's the idea of closure. So closure nothing but you should include the first symbol is null symbol. Second string is the symbol is repeated 1 time. Third string in the particular language is the symbol is repeated 2 times. Next is the symbol repeated 3 times. So on so the symbol is repeated a number of times. This is the idea of the closure. And here I am showing the relevant examples also in regular expression because the understanding closure is very important. A star means here I give the some clear definition. What the definition is 0 or more occurrences of the particular symbol A. Here this is the taking example of A star. First is include a null value. 1 time you take the A, 2 times you take the A, 3 times you take the A, 4 times and so on. So this I think closure of A. The closure that can be defined by the A power asterisk symbol is called as a closure. And other than closure, one more operator is there. We have the two options. It's a closure. It's not closure, but you obtain the value of the A place from the closure value. How nothing but you take the closure of A and exclude, not include, exclude null symbol. This is a formula you should follow. A power plus means A star is the closure. You know the idea of the closure, but what the A plus nothing but A plus is always obtained from the closure of the A value. The closure of the A is A star. From that you have to subtracting the means you can excluding this null symbol. This called as A plus. So hence you have to check this what the set is. A plus this called as A plus set. So here you covered every string of the A star except this null value, except this null value. This null value that should be minus something, but you can exclude it. So these are the ideas of A star and the A plus. So again we have to go recap the what are the basics of the regular expression is. One is for the pi. We define the pi. The corresponding regular language is empty. We have null symbol. The corresponding regular language have the one element but null value. So any symbol is there. Regular language have the only one string. Its symbol is x. Suppose we have defined the x star. We have defined the x star. The symbols are called as null. We should start with the null. X, 2x, 3x, like this. Suppose the symbol is x plus, you can exclude the null value. We consider remaining symbols here. That is x, 2x, so on so. This is called as x power plus. We see some other relevant example of regular expressions. Means here I am trying the examples for you generate the language or we find the regular expression. One more example is we know the regular expression and we have to find the regular language. Here I'm asking the question is write the regular expression for the language of all strings over 0, 1 over 0, 1 means trying for language is accepting all types of the strings. What the symbols you are using? The symbols are 0 and 1 means it may be for single 0, single 1, 0 1, 1 0, 0 0 1, any combination. So that case we must remember what regular expression you can take nothing but 0 plus 1 whole star because of which is equal to 0 star 1 star and a whole star. That is you can deriving like this is a null value 0 2 zeros so and null value 1 2 ones so on so. You can concatenate you can apply the concatenation. We're getting all symbols. Null with all other symbols. Null, 1, 2 ones like this. Next is 0 with remaining symbols. 0 with null is 0, 0 with 1 is 0, 1. So we have to see that we're getting all types of symbols. So the answer for regular expression for the language accepting all the strings over 0, 1 nothing but blind you can say that you must remember the answer is 0 plus 1 whole star. So this is the answer because it covers any string. The string having it may be first zeros, then ones, or first ones, then zeros, or only for zeros, or only for ones. It covers any type of strings. What the symbols of what the symbols I am taking here? Two different symbols. We also am taking the two different symbols. Suppose my question is changed. Write the regular expression. Write the regular expression for the language accepting all the strings over not for 0 1 over 0 comma 1 comma 2. The question is why the regular expression for the language accepting all the strings over 0 comma 1 comma 2. In that case the answer is 0 plus 1 plus 2 whole star. So like that based upon the symbols and here there is no constraint. We should write the regular expression accepting all types of strings over the total for three symbols and given 0 plus 1 plus 2 star. But in the given question is only for 0 plus 1 given. The answer is 0 plus 1 star. So you have to check another question is what is the regular expression for the language accepting all the strings starting with 1. There is some constraint given ending with 0. So here you should the starting symbol is 1. You should starting with 1 and ending with 0. What is the between is? Between 1 and 0 is? It may be for any symbols. Any symbol, any string that can be defined by the expression is called as 0 plus 1 star. So finally the answer is 1, 0 plus 1 star 0. So as per the given question is starting with 1 and ending with 0. And if you have to check another question is why the regular expression for the language starting and ending with a. We should take the conditions constant is starting and ending with the a, and having any combinations of b's between any combinations of b's between. So first you try to solve this question. Say any combination of b's between. What the any combination is? Maybe a single b, maybe for two b's, maybe for three b's, so on so. Actually, it is called as b plus. Okay, and one is starting and ending with a is starting with the ending with a. This is a final combination. So starting and ending with a, yes, starting and ending with a between any combination of b's. Any combination, but it may be single b combination, two b's combination, or three b's combination. So sometimes no b's you are assuming. You can modify this also called as a b star. The exact answer is the a b star a. Okay, or a b plus a you also get. Here I think sometimes no b's also we get one symbol. Here starting with the b also. So this is a correct answer, but the correct answer is this for the correct answer a b plus a. Because of the b plus, but it may be start with the single b, two b's, three b's like this. Umar, so write the regular expression for the language accepting all string in which any number of a's followed by any number of b's followed by any number of c's. Any number of a's. First you take the this case is any number of a's. It's called as a star. Means here we take no a is not generated, null symbol. Single a generated, two a's generated. This is the meaning of any number of a's. It's called as any number of a's. Followed by again you are trying to find any number of b's. Any number of b's. The same assumption b star. Followed by any number of c's. Finally, the answer is a star, b star, c star. What the b star is? Suppose b is not generated, well, single b, two b's, also, and c is null, c, two c's, like this. This I think the expansion idea, but you must write this expression is okay. Okay. So this I answer of any number of a's followed by any number of b's followed by any number of c's. You check the fifth question is write the regular expression for the language over sigma equal to 0. Okay, means you must take the alphabet symbol is only 0 symbol only having even length of the string. So means null, the number of zeros are 0. Two zeros is the even length, no? I'm asking here even length of the string. Four zeros. Okay, even length. Even length nothing but two zeros, four zeros, six zeros, like this. Extend the idea. That type of strings are generated. So how can you express this? Simply you can express the common expression is 0 0 whole star. So 0 0 whole star nothing but it may be for repeated, no repeated, single time repeated the pattern two zeros, two times repeated the pattern is four zeros. You are getting same answer. So that is the answer for why the regular expression for the language over sigma equals 0 having even length of the string. Okay, you must remember. And one more question is, so write the regular expression for the language having a string. We should have at least one zero, at least one. Here the question is somewhat complex. The question is at least one zero and at least one. At least one zero, at least one. Okay, and after that, maybe for 0 plus 1 whole star plus 0 plus 1 whole star 0 plus 1 whole star, and or at least it may be start with the 1 also. Next we are getting another pattern 0 also. We also 0 plus 1 whole star 0 plus 1 whole star 0 plus 1 whole star. The meaning is at least 1 0 and 1, at least 1 0 1 1 that is covered. If 0 plus 1 star remaining other cases 0 plus 1 star given, and one more pattern is here. sometimes you should start with at least one single one and a single zero also. You can take the both ideas, or nothing but you must add the plus. So finally, the answer is you can read as 0 plus 1 star 0, 0 plus 1 star 1, 0 plus 1 star plus. You can read as this string. This totally for the answer for the given question is at least one zero and at least one single one. So with this today we have completed the idea of the regular expression, definition of the regular expression. What about the relationships between language, strings, and finite automata and regular language? And what are the basics of a regular expression? What are the some other formats of the regular expression? What are the closure? What about their problems? That is we have discussed today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.